Okay, this is module 3, and it's an interesting one. We're going to take the concept of radar into the navigation context. So I'd like to talk to you about relative indexing and a method to position yourself in the channel, and also to evaluate whether or not other vessels are embarrassing your navigation within the channel or using water they're not supposed to, etc., or coming into your lane. So that brings us back to this idea of equivalent systematic observation, which is, I keep waving the rules of the road book around because I got it on my desk here, but we're going to revisit that idea in Rule 7. So that's what's coming forward here. This is Module 3, and I hope you enjoy it. Hey everybody, let's keep it relative. Let's talk about indexing. So we saw earlier on the parallel index ideas on the screens. Those are electronic bearing lines, and they can be set for relative or true. I'm going to use all relative index marks today relative to indexing around the ship. I want to show you a trick that pretty much was developed for Houston Ship Channel, but I can apply a lot of different places. Anywhere you have known navigation markers that you can count on outside of your channel, potentially give you some distance to the middle of the channel, let you index yourself relative to those, and also to the traffic. And I'm going to open up my rules of the road book, and I put a little orange marker in here to talk to us about Rule 7. You see Rule 7? Whoop, right over there. Rule 7, and I highlighted a section in Rule 7. So if you're curious about this, you can look at it up as well. And Rule 7 says, B, proper use shall be made of radar equipment. That's what we've been talking about here all day, right? And if fitted and operational, including long-range scanning to obtain early risk of collision and radar plotting. Or, this is our big point, equivalent systematic observation of detected objects. So, if you're not doing radar plotting, which I would gather none of you in Pilotage are doing radar plotting, and very few people on the bridge are doing radar plotting either, you need to have an equivalent method of systematic observation in place. It might be a pretty weak argument to say, well, I just stare at my equivalent systematic observation to radar plotting is just glassy-eyed staring at the radar using my vast experience in radar. You might be able to sell that, but I don't know. I like having a couple marks and setup on the screen that I can fall back on, so I don't end up like this cat jacked up on the breakwater in Miami. So let's just take an idea and take it forward here. If you check it out, I keep a units table. I even made a little luggage tag out of these once, really little card. This was the size of a business card. But it's nice because when you're on the radar and you want to know what, look over here at my little pointer gadget. Let's say an 800-foot channel. And, that's 400 foot to the middle of it, which means that a 0.066 is the measurement from the middle of the channel to the edge of it. So if you're trying to convert your feet that you know where the width of your channel and distances are in feet, or to quarter channel marks to radar marks, this is what I use it for, and vice versa, going from meters the other direction if you're a meters person. So this is the idea. If, like I said, it was set up for Houston, but it would work anywhere. Just Houston's an idealized channel. It's 540 feet basically of total width. It's got 2 barge lanes. This is that 540 rather. It's got 2 barge lanes on either side. But the nice thing about Houston is outside the channel, there's these physical day markers. There's reds and greens, and they're 1,000 feet apart. In the middle of the bay, which maybe it's like this in Tampa where the bay's open and there's markers. Or maybe in one of the other ports in Florida, has something you can index on. It's outside the channel, but you can count on to see with the radar to give you a middle. But I kind of like this in Houston because you can count on these things. If a towboat hasn't, pushed one over, there are big metal poles sticking up out of the ground with a day marker on them. Means they're really clearly seen on the radar. So they're 1,000 feet away, which is 0.165 from the middle of the channel. So I got some ideas here about equivalent systematic observation to make me compliant with my rules of the road, and also just to give me some kind of warm and fuzzy feeling that if I get in front of a radar, I can gauge what's happening where I am in the channel. I can use it in conjunction with my portable pilot unit. So when I see the PPU says I'm 65 foot right, I can look back over on the radar, and if I've got these marks on the radar and they're slid over a little bit to the right, and I can see how it's coming by maybe it's got a little daylight on that marker now on the side of the channel, and I'm getting comfortable with all that and start to see I can see the radar makes sense to me now because I'm correlating it to other things. That's what I believe this method's for. Okay, let's talk about using VRMs, variable range markers, for range indexing. And this could be the first layer, if you will, in your equivalent systematic observation in order to make you compliant with our rules of the road assessment of traffic in your channel. So if I'm using my laser pointer, here we have VRM number 1 at 0.044, because in this channel there's 500 feet between for the ships to operate in, which is familiar. I think in Tampa, range cut B, cut C, cut D are all in that 500 foot range for the most part, right? So if you could, so there's comparative channels like this throughout the United States and in Florida. So we have our first VRM is at 0.044, which gives us the kind of, that's around the ship from the origin of the radar. The second one at 0.082 runs us out a radius, because the VRMs are radiuses, right? So we know the diameter between the two day markers is 1,000 feet. So the radius is 500 feet, and 500 feet is 0.082 on our radar. So we run 0.082 out, and then we observe the radar echoes cruising by. Hey, here's a magic moment, right? So if the greens come down and it's right here at the 9 o'clock position, and the red's over at the 3, and I see that, and I see that that outer ring is perfectly balanced between the two of them, so I think mentally on the radar, I'm in the middle of the channel. This is that opportunity to glance over at the PPU and co-author your position and see if what it looks like when the radar has a physical connection, right, through the radar energy to the echo. What's the estimate from the GPS about your position? And is the GPS measuring your position differently than the radar position? So when you get these moments where things are just lined up perfectly on the radar and you think you've got, boom, I'm right in the middle, glance over at the PPU position might be ahead of you, for instance, and it may show you you haven't yet to get to that position, so it's slightly behind perhaps. And this is the opportunity to make sure, and the radar's the truth and the GPS is a guess. So and the GPS could be subject to all manner of different problems which the radar isn't subject to, like the datum or the antenna position on the ship is not in a consistent common reference point relative to the radar scanner origin, and could be in a different position. So this is your piloting opportunity to find out what those differences are in an instant. Just glance at it, base yourself off the radar, glance at the PPU, see what's different, log that mentally, and then it won't sneak up and bite you later. Parallel indexing with a range ring. Now, if you don't want to use that VRM or range ring out at that distance, you could use both. You could use it in conjunction. You could take, therefore, a parallel index line or an offset electronic bearing line that is parallel to your heading line, and actually to the course, in this case down the center of the channel, and just drag the origin out, run it tangent to the VRM, run it out in front of you, lock it down over there. So now the origin of the EBL is anchored here astern of you, and as long as you see a couple of these day markers and they're all on the starboard side of that line, and that line's kind of lined up with them, well, you're lined up in the middle of the channel. So now we've got an equivalent systematic method for observation of our location in the channel, which is important for rules of the road, because if we need to maneuver for another vessel in order to open up for a meeting situation, or to negotiate a overtaken situation, I have a radar method now to help gauge where I am in the channel relative to that event. And that seems systematic to me and defendable under Rule 7. So, yeah, why not? And let's, this is the most simple version of it. Let's try to, make it a little bit more complicated. Let's talk about it. Let's say there's a tow in the channel. So in this case, I want to know, is that tow doing a good job in staying over in that barge lane? Which in this case, this is that 540-foot Houston ship channel for the ships. Then there's that other 260-foot section over there where those barges are safe because they're in about 16 feet of water. And then out over there with the elephants in the middle of the channel that are running down the middle, they're going to stay clear of them. So if you wanted ESO, equivalent systematic observation, you look up forward and you go, I can visually gauge that this tow is not over there where it's supposed to be. And how did I do that? Well, I took my 0.044 range ring, or my VRM rather, put it around own ship to index where the channel of the ship channel is, and ran a tangent EBL or parallel index line, which I think is better, because then that leaves you your EBLs for other purposes. And of course you want to use a PI line that has the R by it. It's relative. We don't want true, because then they'll just stay put and you'll just steam by them. You want them to stay relative to own ship, right? This is relative navigation. So I can put my relative navigation marks. In this case, I got two relative navigation marks. I got these two, EBL1, EBL2, or PI1, PI2. And when I look at it, I go, I'm in the middle. I glance over at my PPU. And it says, what, 10 right or something. I'm close to the middle. And sure enough, the parallel index line is now tangent to the nav markers going up the channel in a straightaway. And those things are now consistent. Then I've got my secondary PI line that's running up next to me. And I can use it to gauge whether traffic's in or out of the channel. So you could adapt this idea, to your own pilotage and set up your own ESO method that fits what you do on an average day. I wanted to show you how I did it here. I even took this because, why not complicate something, right? So let's go ahead and add another line to it. In this case, I wanted to be able to judge the contacts that are on my starboard side, whether or not they're in and out of the channel over there. I wanted to see if I was in the middle, and also if I had traffic that was approaching, was it inside my comfort zone? So what I decided today, part of my equivalent systematic observation for maneuvering with traffic, I have this oncoming traffic. In this case, I made it a tug and barge, but it could be a ship, right? Any radar echo up ahead of me. And I wanted a 200-foot buffer from the origin of my radar out to what I was going to allow alongside the ship on the port side for meets. So I thought 200 foot worked in this situation. So I put 200 foot over here. That's 0.033 because I had my handy table and I looked it up. It's on my little luggage tag. Yeah, 0.033. Gotcha. And I ran PI number 3 out there. So as long as contacts ahead of me are outside of the PI line as we're meeting, I know I'm going to get my 200 foot from the scanner, which is a little less because you got to take the beam of the ship, so skin to skin on the vessels will be less, but regardless, I set my PI line up relative to the origin of the radar scanner. So this is my method for Houston. I might throw my 3 lines out today, and sometimes I'll take that if I know I'm going to duck and dive over, and I don't want to run more than 100 feet, let's say, to the right when I brake for oncoming traffic, then I might even take this to another level and say, I'm not really evaluating barge lines today. I want to know when I'm 100 foot over in the fog without the PPU. You're like, yeah, how do I exactly do that? Well, I take that PI2 and I get my handy little card out, and I know that's 500 foot over here. So I set one PI line at 400 foot over here. Then when I turn and I go to the right and I make my brake, which is about 4-degree brake at what, 6-7 tenths on oncoming traffic, and I make my brake. And I start running across the channel. The oncoming ship's doing the same thing. We're going to meet around each other. Well, I just don't want to go more than 100 foot today. Let's say that's my deal. On this ship, that's what I like. I wait for that second PI line because it's relative to me, so it's running with me, and the origin of the PI line is driving across the channel 100 foot as the origin of the ship is driving across the channel at 100 foot. And I get that origin to come over here, and when that PI line is tangent with the nav markers, I know I'm 400 foot across. So again, steering and sailing rules, I've met my requirements for Rule 7. I have an equivalent systematic observation method that uses lines and marks on the radar in a relative fashion to, establish safety. And I'm on track here. So this is a method. I thought you might like it. This was for Houston, but you can certainly adapt it anywhere you got a straightaway, you got a little time to set up the radar. You do something simple that would work for you. It might not work for you in all sections of your route, but at least it's set up so that when you get out in the main channel, you got something in your pocket, and you got a defensible method that you use every time on the system of the radar that helps you equivalently systematically observe your radar targets. And this is it's another piece of that idea, this passing distance, little buffer zone. Oh, here it is. Look, I went ahead and I took the desired distance right of center line, and I transferred that over onto the starboard side so that when that PI line is tangent with the day markers, this one, the other one will be 100 foot out to the, off to starboard. This one will just be coming in there, and that means that I've displaced myself from center line of the channel, CL, over 100 foot. Origin of ownership is now running off to starboard at that distance. So that's that idea we talked about the other previously, just illustrated here. And yep, something to think about. I think it's cool. I like doing it. It's a cool idea. And that's the PIs to set it up. Okay, everyone, I'm going to give you another example. This one's in Sabine, Texas, and some of you might have seen this before, but we'll take a look at it. This is trying to set up a jetty end approach into Sabine. And in Sabine, the entrance channel inside the jetty does not run parallel with the breakwater. So also the breakwater, which are like rocks sticking up out of the ocean, they're really close to the ship, so it'd be difficult to use them for parallel indexing because they get so close, they get inside of your minimum radar range to give you a clear picture. And also the slant angle, as many of you know, radar is required to have 25-degree minimum angle, so if the height's really high, even at a 25-degree angle, you might miss those near things. And then we get hourglass effect and all kinds of problems. So I believe it's better to index off something that's farther outside the channel. So this was just an example of how if I was in a pilotage and I'm in day-to-day all the time in a place, I would lay out some of these things. And I was hoping to do some in Florida for you as well here after this, but I'll show you Sabine. So I use the rear day marker as a guide, and then there's a marker on the end of the jetty here that's on the west end of the jetty, and it wouldn't line up directly with the beacon on how I wanted to use it. So I put a VRM offset in the charting software. This is using CIQ, and I made a virtual point, a wee bit here off to the west of that marker, and I laid this out on the chart. So that was going to be one of my parallel index lines I'd use on the radar later. So I usually do these setups on a chart first, and then write them down in a little book so that I've got them in my back pocket and I can use them for a radar setup. Now just some ideas here. So the reason being, we've got ownership is in the channel making the entrance in. Of course, the current runs across here. It's windy offshore. So we want to run this PI line, like 0.18-ish to the west at a bearing of 338 in this case to adjust the ship. And I wanted to see two things in the future. So I didn't use these markers because these can be buoys and they don't, necessarily line up alongside the channel. So I'm just using that as a subjective issue. They can be on a watch circle of chain. So I wanted to get something hard. So I got the end of the jetty, and then I got that rear range slightly to the west, and I used that as my PI line. And notice Own ship is represented here by this VRM and in the middle of the channel. So if I can keep that PI line lined up with the end of that jetty and that kind of false location I had in the background, that'll track me down the entrance channel nicely, and so I was able to create that. It runs in the simulator kind of nicely, so I set that up. Here it is, slightly to the west of the rear front range. There being the rear range. Because I don't want the middle, I want offset, because I'm using parallel index offset to keep it aligned. So as you see, I've got an extreme current in here of 1.5 knots, and the head flash on the ship, we're staying on the high side of the channel, so we're on the windward up side of the channel, so we can set down across it if we need to. And if the master was standing next to you while you're piloting, you'd look out the window and see both navigates on the starboard side. It makes them nervous, but this is the extreme drift angle we need to drift down the channel. And yeah, working good. So as we are set up there, this orientation between own ship origin and the relative mark is set up alongside the channel, so I can ghost down this channel and keep my drift angle established against this current and do that piloting thing. You can range in and range out, and the relative index mark will lay right down on the west side off to the port. And if you keep it lined up with that end marker here and here, that means that you are relatively correct in center of channel. So I guess the larger point is you got to be careful in pilotage. It's tempting to try to measure things that are really close to you with radar. It's better to have something a little farther away to give you better radar clarity and to line that up. So this is the look on the ECDIS, which shows the course over the ground, making the entrance channel. We're doing pretty good there. And there's the head flash on the ECDIS, showing even the reds are on the port side. And we've got a pretty heavy drift angle on the ship as we're ghosting down and kiting down the channel. And on the radar, the PI line was going right across this jetty end. There's a marker on the jetty end. The chart, not to be trusted, right? We have to know what's really out there. And so in the case of pilotage, we know there's something out there that we can grab onto. There's a big steel thing right here on the end, and that is radar conspicuous. And then of course that front range is clearly radar conspicuous behind it. So that's how the PI line was set up for the radar. Okay, that's the conclusion of Module 3, Relative Indexing and ESO. I hope you found some nuggets of cool information in there that make you want to strive to go back into your pilotage and set up some EBLs and VRMs to assess your position in the channel. And, potentially to set up a system of marks that you could argue is your equivalent systematic observation in the use of the radar. So, all good. Thank you very much. Next module is 4, where we're going to talk about the new things that are happening with GNSS, which is our global positioning system, and everyone else's, so the global navigation satellite system, and talk about a new type of position sensor as well, which is LiDAR, and just so a little bit of what's new in maritime positioning. That's what's coming next to look forward to in Module 4. Thank you.